So, like I was saying, so we understand what we are going to do here, Abby, right? That in order to do this multiplication, indices has to be applied. And since we have times in between these and these, we are going to go with what? The first law of indices. Hope that is clear. Now, but before we use the law of indices, that one talks about a situation where we have the same base. But do we have the same base? Since we are not having the same base, so that means we can adjust this to having this base, right? That means we want to rewrite 9, having base of what? Of 3. And 3 raised to power what can give 9? So in this case, we say 3 raised to power 2. These two will now combine with the power we have before, Abi. So in that case, we can decide to use brackets. What? 2s plus 1, Abi. Then multiply by 3 raised to power x is equal to, yeah, okay, I said we should leave this one for now, Abi. It's because of your level. If we've understand it to some level, we can do it straightforward or once and for all. So let's still leave this one as 81 raised to power x minus 2. Now, base is the same, Abi. Whenever our base is the same, what can happen? Or can we open this bracket first? Can we open the bracket first? Okay. Can we write it as 3 raised to power 2 times 2x? 2 times 1, 2. Multiply by 3 raised to power x is equal to 81 raised to power what? X minus 2. Can we see that? Now, base is the same. So that means we choose a single base, Abi. And once we do this, times will now be acting as what? Addition. What will it now be adding? It will be adding the powers. Alright? So there we can say 4x plus 2 plus x is equal to 81 raised to power x minus 2. Right? So let us clean this place first by writing it as 3 raised to power 4x, we add x, Abi. X we attract s. So that becomes 3 raised to power 5x. Abi, this is a constant term. We say plus 2 is equal to 81 raised to power what? Raised to power x minus 2. I hope this is clear, right? But look at this base here. So we can say adjust this one. This is a form of indicial equation where the two bases are number. When the two bases happens to be number, one of the things you can do is what? You can adjust the bigger of the two bases, Abi, to look exactly like this. So in that situation, I can say 3 raised to power 5x plus 2. What I have here is equal to 81 can be rewritten as 3 raised to power 4 into x minus 2. Now, if you want, you can say this base cancel this base, right? And we are left with 5x plus 2 is, you can open the bracket, 4x minus 8. So here I have 5x minus 4x is minus 8 minus 2. I hope it is clear. 5x minus 4x, that is x, Abi, is equal to minus 8 minus 2 minus 10. Then the value of x we have to find there is what? Minus 10. I hope that is clear. Are you sure already? Okay. That's our second question. The third one, we have 3 multiplied by 9 raised to power 1 plus x is equal to 27 raised to power minus x. Well, in order not to waste too much of our time, right? Because in solving this question, we wasted a lot of time. Is it clear? There's another approach we can use to make this solution to be as fast as possible, right? So we can see every number we have here, right? It is possible for us to express them in base of 3. Is it clear? Or if you want me to continue with this style, there is no problem. But remember, the most important thing is you understanding it. So if for now, the way we are doing our maths is not at higher pace, but we still understand the main concept, I do not have problem. The most important thing is you understand it, right? Once you understand something, then you will also work over words, doing it at a very faster pace. So, will you want me to continue with the style I use here? Can I continue with that, Abi? Okay, let me say because of your level, let me continue using the same style I used here. So in that situation, I have multiplication here. Let me adopt what my multiplication will become. Is it clear? But I want you to know that we have other way of doing it as fast as possible. But because of your level, we are just learning it. Let's continue with that style you are used to. Can I continue? So in this situation, look at there is times here, right? Because the two numbers involved here, one of them is index number, right? Because one of them is index number, you cannot do direct multiplication. That's one of the lesson laws of indices want to teach us. It is telling us how to multiply number in index form. It is saying that whenever you have a numbers in index form, you cannot do direct multiplication. So normally, I think this thing is not index number, right? That is, this thing do not contain an index power, right? The best thing we should have do is what? To say 3 times 3 and say 27. But once you have index number, multiplication cannot be done in that way. Now, how to do the multiplication? You must apply laws of indices. I hope that is clear. And you can see between this and this is what? A multiplication sign. And when you have multiplication sign, which of the law do you use? You use law 1, Abi. And in order for law 1 to work very well, the base here and the base here must be the same thing. Is it clear? So since this base is bigger, it is the bigger one we adjust to the smaller base. Hope that is clear. I hope it is clear, Rodia. What you now do is 9 we're having here. How can I express it as index number having base of what? Of 3. How do you do that? 3 times, in how many times do you repeat 3 to get 9? So when 3 doubles itself, Abi, when we say 3 raised to power what? 2. So here I can say 3, or I can as well say 3 raised to power 1. Hope that is clear. Multiply by 3 raised to power 2. Combined with the power we earlier have here, we say is equal to 27 raised to power minus x. Is it clear? Are you sure? Now, can I open this bracket first? Or I should continue with applying law of indices? Open it first, okay? We say 3 raised to power 1 multiplied by 3 raised to power 2 times 1. 2 times x is equal to 27 raised to power what? Minus x. Hope that is clear. Okay. Have you written this? Okay, let me just use this smaller part here. That one should be enough. So in case you see it, for those who are here to write this, I will give you time to copy it now. Okay, let's continue. All right, I can still use this place. Now, our base is the same, Abi. Times will now change to what? Plus. We now have 3 raised to power 1 plus 2 plus 2x is equal to 27 raised to power minus x. So I asked you the other time, but you said you prefer this style because the majority of you are just learning it. Is it clear? Understanding is most important. So when you understand it, over the time, I don't need to tell you how to do it fast. You will be doing it as fast as possible. You can just look at that thing and do it once rather than step by step as we are doing it here. You remember this approach waste time, right? But one thing is more important than wasting of time. That thing is, do you understand the concept? Is it clear? So by the time you create time to be solving questions on your own, most of these things I am talking about, you will understand it more than I'm saying it now. Then you will learn to do it as fast as what? As possible. So that is the reason why it is important to always what? You must practice. Practice when you are not given assignment. That is what shows you are ready to learn or to study mathematics. But if you are still relying on what teacher is doing in class, you are still not ready to know mathematics. You are only ready to do what? To participate in class. Is it clear? Are you sure? All right, to continue with this, I can combine this place, Abi. So in that case, I will write it as 3 raised to power 3 plus 2x. Somebody said 5. Eh? There's nothing like 5 here. Is equal to 27 raised to power what? Minus x. Raised to power what? Minus x. Right? Now this is now an indicial, though it is an indicial equation we are solving before. Right? Another thing that can happen is, in order to get our answer here, right? Base in the left side must also be equal to the base in the right hand side. Is it clear? Which shows this 27 we have here, we want to rewrite it as 3 raised to power something. Do you get that? And 3 raised to power what will give 27. So here we say 3 raised to power 3 plus 2x is 3 raised to power 3 into minus x. Hope this is clear. So if you want, cut the base. So we are left with 3 plus 2x is equal to minus 3x. Right? So here what can I say? Can I say that, how do you want to move it? It depends on you. How do you want to move it? So x will be here, Abi. So that means 2x plus 3x is equal to minus 3. Right? Let me separate it and use this part to complete it. So 2x plus 3x here, 5x is equal to what? Minus 3. To get x now, what do? You divide both sides by 5. So s cancel s. So we now say our final answer is minus 3 over 5. Is that clear? Is it clear? Oh, yeah. In case we need to copy it, let's quickly copy that. Oh, yeah, hurry up. Are we through? Are we all set? Are we sure? Can I rub it? Walaikum salam. Sheikh, salam alaikum. Are we set? All right. I should rub everything. All right. The next question is this: 3x raised to power 3 is equal to 24. Now, in solving this form of question, right, what should happen is that this our index number must not have any coefficients. right? So what do we now do? We remove the coefficient, abi. How do you remove the coefficient of 3? We first of all divide by 3. So that means x raised to power 3 here is going to be what? 24 over 3 is what? That is 8. Can I continue? All right. So what do we now do? Remember this time. One base is a letter, the other base is a number. How do we treat that? How do we treat that? What we do is we want to cancel these 3. How do you cancel these 3? So first of all, we need to realize that this is a fractional number, 3 over 1, abi. Cancelling it means we multiply by 1 over 3, and 1 over 3 will also be placed here. So this 3 cancel this 3, this one cancel this one. We say x is what? 8 raised to power 1 over 3. And how do you deal with 8 raised to power 1 over 3? This is a fractional index rule that we are going to apply, abi. So in that case, we say x is cube root, abi, or third root of what? 8 to the power of 1. So x here now become 2 raised to power 1, and x is equal to 2. Is it clear? So that's that. The next number, the next number, the next number is this. 2 raised to power 2x multiplied by 2 raised to power 3x minus 1 is equal to 1. See, I want you guys to realize one thing. There are some differences between what we are doing today and that of yesterday. Do you know why? In this case, we are just jumping straight into applying our laws of indices, abi. Why? Because in between those numbers given to us, right, we do not have plus or minus. Is it clear? If combining this term to this term has minus or plus in between them, do you get it? We have to go to one place first before we can come and apply law of indices. Is it clear? But if you ask me a question, why not saying that, okay, 2 raised to power x and call something, create another name? You remember the pattern we used yesterday, abi? This one will not follow that pattern because this is what? In a sensible form. It makes sense in this way. But once in between an index number and another index number, you have plus or you have minus, you adopt exactly what we did yesterday. Hope it is clear. Rodia, is it clear? Now, so to continue with this, what do? You can say we have multiplication here. Is it clear? So since you have multiplication, we want to apply multiplication rule or multiplication law of indices, right? And the first thing that must happen if we want to use that law is that what? The two bases must be the same thing. And look at the board. This is a very perfect question. Our base is the same, right? Once the base is the same, what do? Just make a choice. You pick one out of those bases, abi. What now happen? Times in that situation now changes to what? Addition. So that means we say 2x plus 3x minus 1 is equal to 1. So when you observe this place, it is the same thing as 5x minus 1 is equal to what? 1. Right? Now, what do? So these other parts too must also be written in index form, abi. So writing something in index form contains two things, base and what? And power. What base will this thing have? Same base this one is using, abi. So that means I will write it as 2 raised to power 5x minus 1 is equal to 2, and 2 raised to power what will give 1. So it will be 2 raised to power 0, so that 2 will cancel out 2. We can now say 5x minus 1 is what? 0. And 5x is equal to 1. Yes, then we divide both sides by what? 5. So x in this case gives what? 1 over 5. I hope that is clear. So that's that. Okay, before that, we have 1 over 2 raised to power x is equal to 8. Remember the other time we solved this question, we cross multiply, abi? The third question we solve today. We cross multiply, Abi. So cross multiplication is not going to be possible in this. Well, it is also possible, but though let's not use that. Do you get it? So this is a straight indicial equation, Abi. Can you see that? What do we want to do here? We want to make sure that, first of all, okay, let me put it this way. When dealing with indices, decimal and fraction, we don't want to deal with them, Abi. So what you would rather do is, or let me say, this thing is a number having power, Abi. So since this contains power, but what is carrying this power must also be in index form. Can you see that? What we want to do here is this 1 over 2, we want to write it in index form. Can I continue? Can I continue? So we want to write it in index form. If you want to use there is one local method I observed here that you can use. Do you know that local method? I should tell you, but that one is a waste of time. Let's go straight into what we want to do. Let me write this 1 over 2 in index form. That will be what? 2 raised by minus 1. You remember that one we combine with x, we can say times x. Is it clear? So also we can say this 8. We want to write it in index form. For this one to be in index form, it must have what? Base of 2. You first of all say 2, Abi. How many times do you repeat 2 to get 8? So that is 2 raised by 3. So you can break this and say minus x is equal to 3. Now, this is like saying minus 1x is 3. Is it clear? So to remove this minus, to get x, we divide both sides by minus 1. You know, this cancel this, Abi. S finally gives minus 3. Hope you understand why it is minus 3. Do we understand why it is minus 3? So what happened is, this 3 we have the as plus before it. Do you remember? And when it comes to division, we say plus divided by minus, that gives minus, and 3 divided by 1 gives 3. So our answer there becomes what? Minus 3. Hope it is clear. So to solving a single question, there are many ways by which you can solve it. There is another means. Let me use that means for you here. Or, if you wish to use your cross multiplication, do you know what you will do? First of all, this power must be given to them differently. I remember I told you that time that we distribute this power to this and this, Abi. You can as well say 1 raised to power x over 2 raised to power x is equal to 8 over 1. You can now cross multiply. So meaning that what? 1 raised to power x is equal to 2 raised to power x times 8, Abi. And we can say 1 raised to power x is equal to, here, this will be 2 raised to power x multiplied by 2 raised to power 3. Then we say 1 raised to power x is 2 raised to power x plus 3. Abi, let me finish it here. Right? We say 2 raised to power 0 times x is equal to 2 raised to power s plus 3. These two will cancel these two, Abi. 0 times x, 0 is x times, okay, is equal to x plus 3. So to get x, what do? You move plus 3 to this side, Abi. Right? So we now say 0 minus 3 is equal to x. Minus 3 is equal to x. Therefore, x is equal to minus 3. Is that clear? So the choice is yours. But in case you wish to use cross multiplication, the power must not be combined. You must distribute the power. I hope it is clear. Hope it is clear. So you can do it this way, you can do it this way. But I bet you using this style is look faster compared to using this approach. Is it clear? You also can discover more ways to solving it when you create time to solve questions on your own. Remember, I always tell you, to be able to be a successful mathematics student, you always must solve a lot of questions not given to you by your teacher. If your teacher is still the one directing you to solve this, solve that, it is still a sign that I'm not ready to know it. Once you are ready to know it, nobody will tell you to do what? To read. Is it clear? Not only mathematics, it is applicable to any subject you want to do in school. Please cultivate that habit of what? Practicing on your own. Let your teacher know you are doing it by saying, master, while I was doing this, I got stuck in this area, I do not get in this area. That is how I will know. But the best, or let me say the maximum I can tell you while we are in class like this is we can solve a lot of questions. But even if I solve 100 questions in class, it is still not enough for you to be good. If you want to be good, it is within. Do you get it? So you have it. Your Y pass question is there, your jam pass question is there. Now that we have covered everything we want to learn in indices, right? So you should be determined that anything that has to do with indices in jam pass question, I want to make sure I want to solve all of them. Anything that has to do with indices in Y pass question, in Eco pass question, I want to solve any question I come across. From my master's book, anything that has to do with indices there, I want to solve it. It's only when you have this intention that you are ready to know this thing. Do you get it? Once you still rely on teacher's classwork, teacher's assignment, solve questions by your teacher, you are still not ready to know it. For you to show I am ready to know it, you must be ready to do what? Do what your teacher do not ask you to do. I hope that's clear. So we'll move to the next and which is the final question. Can I rub this? Are you sure? Okay. Now what we have here is 0.25 raised to power s plus 1 is equal to 16. So like I always tell you, indices doesn't play with what? A decimal number, right? Anytime you have a decimal number, what do? First of all, change it to fraction. Then from fraction to what? To index number. Is it clear? So here, 0.25 can be written as 25 over what? 100 raised to power what? S plus 1 is equal to what? 16. And where possible, let's try and cut this thing, right? We can see 25 in 25 is what? 1. 25 in 100 gives what? 4. So we have 1 over 4 raised to power s plus 1 is equal to what? 16. Do you know this thing? I can rewrite it as 4 raised to power minus 1 into s plus 1 is equal to 16. Do you know? Do you know? Rodia, is this thing clear? So which means I can write it as 4 raised to power minus x minus 1 is equal to, do you understand this? When I write my 16 as 4 raised to power 2. Is it clear? Then this 4 can cancel this 4. We say minus x minus 1 is equal to what? 2. So minus x is 2 plus 1. Is this clear? Is this clear? Now, to continue, what do? Can I rub this? Or you're still writing it? I should rub the second part. Alright, no, not everything. Let me just rub part of it. Okay, it's okay this way. Alright, minus x is 2 plus 1. So it shows minus x is equal to 3. Abi? To get my x, what do you do? So I can as well say this is minus 1, Abi. Then you divide by minus 1 by minus 1. And s gives what? Minus 3. I hope that is clear. So that completes the laws of indices, all the exercises that I have for you guys. But as I always tell you, also go and do what? Do your help the most what? The most what? The most good by what? By laying your hand on as many questions as possible.